Now, this is not hard stuff, but I really need you paying attention so you can keep track of all the rules. The directions say write as a single logarithm. So you are going to write log something. So instead of having 2 logarithms, you're going to have 1. When I put these together, I'm going to put them together as a division, because the rule is if logarithms are subtracted, the numbers have been divided. So that follows your exponent rule, doesn't it? When you divide numbers, don't you subtract exponents? Yep. So this is the same rule. When logarithms are subtracted, their numbers are divided. So that's all there is to it. Now, this one, I'm going to do exactly the same thing. I'm going to write log one thing. This is a plus. This is not going to be a division. What do you think this is going to be? A multiplication. But there's something else. What else is in this problem that I didn't have before? The 2. So the first thing you have to do is remember that a number in front of a logarithm is really just an exponent. So this is the log of x squared plus the log of y. Now, you're right. When I put these together, because that's a plus, they're going to go together as a multiplication. And what I'm going to be multiplying is x squared y. Again, your goal, one logarithm. So you have to figure out what's going to go in that parentheses. Any ideas?
Z to the negative third.
What?
Z to the negative third.
Well, it wouldn't be z to the negative third. It would be z to the 1/3. This, whatever this is the exponent. Okay, don't be changing it. So this is going to be the log of z to the 1/3 plus what? Log w 2/3. Yep. Now, since that's a plus, when I put these together, I'll put them together as a multiplication. So it'll be the log of z to the 1/3 w to the 2/3. Okay? All right, what about D? How are you going to start D? Yep, make these exponents. So that's going to be the log of 16 to the 1/2 minus the log of 8 to the 2/3. Now, unlike the last problem, which we just left like this because we couldn't do anything else, this simplifies. Who remembers what 16 to the 1/2 means?
16 square root.
The square root of 16. This means the square root of 16. Fractional exponents are radicals. So we really have here the log of 4 minus the log of what? What's 8 to the 2/3 mean? Now be careful. It's the cube root of, this means the cube root of 8 squared. Fractional exponents. The denominator tells you the root, the numerator tells you the power. So the cube root of 8 is 2, squared is 4. Well, shoot. What's something minus itself?
0.
Yeah, that was just 0. They cancel each other out. They happen to be the same number. All right. What about the next one? Come on, guys, help me out here today.
Do you bring over the exponent on these two?
Pardon me?
Do you bring over the exponent
Yep.
on these?
Remember, ln is a logarithm, so it works just like any other logarithm. So this is going to be ln 2 cubed plus ln 36 to the 1/2. What's 2 cubed? 8. So it's ln 8. Plus, what's 36 to the 1/2? 6 square root of 36, 6. Now I need to write one logarithm. These are being added. So what will I do with these numbers? No, I don't add them. I multiply them, right? When logarithms are added, the numbers are multiplied. All right, one more. All right, what's this? Take care of this. What's that going to look like?
X to the 4th,
X to the 4th, y to the 4th. Perfect. That's exactly right. This comes up. What's this going to look like? Minus. Perfect. Now, these are being subtracted, so when I put them together in one logarithm, they will go together as a division. So x to the 4th, y to the 4th, over x cubed. Can I simplify that at all?
Get rid of the x cubed.
Yep. So it's going to be just x, y to the 4th. Now, the next set of problems are exactly the opposite. So what we just got done practicing here is we took multiple logarithms and put them together in one. Now, we're going to take one logarithm and break it apart into multiples. So ln, break it apart. What's it going to look like? Well, they're being multiplied. I couldn't hear because I was blowing my nose, but I think I heard you say, I hope I heard you say, ln x plus ln y. When numbers are multiplied, their logarithms are added. How about b? What did I hear? I think I heard something right. 3 log x minus 4 log y. Very, very good. Now you can do that in 2 steps if you need to. Does everybody understand why we have a 3 and a 4 out in front there? Everybody understand why it's a subtraction? Perfect. All right, what about C? Radicals do not live in logarithm land. So what are you going to do with that 5th root? 1/5 power. Perfect. So you have the log of x over y to the 1/5. And then what's going to happen to the 1/5? It's going to come out in front. And then Colin, I think I saw you say it's gonna be distributed, because isn't that 1/5 gonna be attached to the X and the Y? And what about that? When I split it, I'll split it as a subtraction. So 1/5 log X minus 1/5 log Y. Perfect. Now that's a little bit different than D. We know we're gonna have a 1/4 power, right?
Just on the X.
But the 1/4 is only gonna be on the X. So this is gonna be the log of X to the 1/4 over Y. So when I break that apart, 1/4 log X minus log Y. Is that all right with everybody? Okay, couple more and then we're gonna do something on our calculators. Okay, so log. Now, numbers are the same as letters, so don't get confused by that. Isn't that a multiplication? So I'm gonna split that and say the log of 100 plus the log of X squared. Now, tell me about the log of 100. We talked about this yesterday.
10 log. For the log space is 10. So, when you break it down, it would be 10 log plus log x squared, or plus 2 log x.
Okay, so this is definitely going to be 2 log x. 100 is 10 squared.
Yeah.
So what's the log base 10 of 10 squared? 2. 2. So your answer is 2 plus 2 log x. Remember, I had something in great big red letters up here on the board. You can't forget those things. The log of 100 is 2, because 100 is 10 squared. And finally, can I do that for this problem? What about this right here? That's just 3. So we have ln 30 plus 3. That's your answer. That's all there is to it. Okay? All right. Now we're going to talk about how to evaluate these weird random logarithms on our calculators. Because on your calculator, now some of the new ones, some of you guys with the brand new calculators, they will do this weird stuff. But those of you like me, our calculator won't do it. So here's how it's real simple. It's real simple. If we want to find the log base 3 of 4. If we want to get a number for that, we don't know what that equals. It's very simple. It's the log of 4 divided by the log of 3. So I think about this. When I look at the way the problem is written, this number is kind of on the top, this number is kind of on the bottom, just the way the problem is structured. So it's the log at the top over the log at the bottom. And then I just go to my calculator. Now when you type it in, make sure you close the parentheses. When you hit log 4, close the parentheses, and then divide it by log 3, we get 1.2619. Everybody get that? Okay, some of you are typing, some of you are just staring blankly. All right, how about the next term? What are you gonna do? What are you gonna type in here? Log base 29 of 3. What's that gonna equal? Log 3 over log 29? Kids, it never changes. It's called the change base formula. That's how it works. It's very, very simple. So log 3, close parentheses, divided by log 29, 0.3263. All right, would you try C and D on your own? Try C and D on your own. See if you can come up with the answers. Please don't let the decimal points bother you. They don't change anything. All right, who got an answer you're willing to share for problem C? 1.2323? And what about D? 1.7354? Perfect. All right, next section. We're gonna do A, we're not gonna do D. But we're gonna do problem 4A. So here we go, let's look at the equation. We've got light intensity and light superior. So we have log I over 12 equals negative 0.0125. Now I is the intensity of the light and X is the depth in feet. So when the question says, what will the intensity be at a depth of 10 feet, what are you gonna do? Oh, no, no, no. Where does the 10 go in? Or X. X is the depth, right? So we have the log of I over 12 equals negative 0.0125 times 10. Wasn't it 10 feet? Yeah. So the log of I over 12 equals negative 0.125. Who paid attention yesterday? How do we solve an equation like that? What does our good friend Mr. Miller say? We're gonna loop-de-loo it, right? So what's the base here? 10. So 10 to the negative 0.125 equals I over 12. Remember, when you have one logarithm in your problem, to get rid of it, you have to loop-de-loo. It's your only choice, okay? So I'm gonna go ahead and raise 10 to the negative 0.125 power, and then times it by 12. Did you get 8.9987?
Yep.
All right, gonna look at section 3.5. It's huge. I don't know that we need to do all these problems, but let's get started. What do you think about A? Solve, no calculator. No calculator. 2 to the x equals 8. What do you think? I hope you're all saying 3. Right? 2 to the third. That's so easy, it's almost insulting. Let's look at the next one. Not quite so easy. What do you think you're going to do with this one? 3 times 4 to the x equals 48.
4.48 to 3.4.
Remember, this is a no calculator thing, so I don't know what you're typing in there. No calculator.
Divided by 3.
Divide both sides by 3. Always. Get rid of that extra number. So what does it say now? 4 to the x equals 16. Oh, what's x? 2. We don't need a calculator. Now, for some of these we will, but not for these rigged problems we won't. All right, now the next one is tricky. Because 8 is not a power of 4. Or I should say an integral power of 4. Right? However, 4 and 8 are not just random numbers. They're very closely related. Because 4 and 8 can both be written as powers of 2. So let's take our 4 and think of it as 2 squared. And our 8 as 2 cubed. These get multiplied, right? So 2 to the 2x equals 2 cubed. What's your kind of natural conclusion?
The 2 and then the fraction thing over 2.
Yeah, so
I mean,
if 2 to this power equals 2 to this power, doesn't it make sense that the powers have to be equal? Think about that. Engage that brain, you guys. So x equals 3x. If we're not going to use a calculator, then we somehow have to have a common base. So we have to have something like 4 to the x equals 16, or we have to be able to get both numbers in terms of the same base. If you can't do that, then you need a calculator. All right, but we shouldn't need a calculator for any of these, so let's look at the next one. Step 1. Divide by 3. All right, so here we go, divide by 3. So 4 to the 2x, don't let the 2x bother you. Whatever the exponent is, that's what it is. What is that? 32. Now again, 4 to a power is not 32. However, 4 and 32 can both be written as powers of 2, because 4 is 2 squared, and 32 is 2 to the what? 4. Well, we can randomly guess, we can sit around and stare at each other, or we can figure it out. 2 times 2 times 2 times 2 times 2. 5 to the 5th. So 2 to the 4x equals 2 to the 5th. So what can we do now? Man, you guys are making it hard. 4 to the x, or 4, not 4 to the x. 4x equals 5. So x equals 5 fourths. Do one more, then I'll make you do one by yourself. Let's look at E. Lillian, what's the first thing I'm going to do in E?
Divide by 2.
Yep, I'm going to divide by 2. So 5 to the x over 3 equals 125. Is 125 by any chance a power of 5?
Yes.
Whose power is it? 5 to the 3rd. So 5 to the x over 3 equals 5 to the 3rd. So x over 3 equals 3 and x equals 9. All right, try F and G. Try F and G on your own. In F, hopefully you divided by 2 first. So you got a 9 and a 27. What about 9 and 27? They're both powers of 3. So this is 3 squared. And this is 3 cubed. Now remember, this is a multiply. Power to power is multiplied. So 2x plus 6 equals 3. How many of you got negative 3 halves all by yourselves? Good deal. Congratulations. If you didn't just raise your hand, you have it figured out? All right. What are you going to do first on this one? Divide by 36. We are not going to be fearful of the fractions. Yes, we're going to have fractions. 9 divided by 36 is 1/4, isn't it? Is there anything special about 1/4? It's 1/2 squared. So 1/2 to the x over 4 equals 1/2 squared. So x over 4 equals 2, x equals 8. Everybody get that one on your own? Good job. That side of the room's rocking it over there. Good work. Now we gotta look at some that look a little different. Let's look at letter J. Looks a little different now. But if you were listening a minute ago, when we did the Lake Superior problem, you know exactly what you're going to do with problem number J. This is a different kind of problem. This is not an exponent problem. This is a logarithm problem. So what do we have to do? Loop-de-loop. So 7 to the x equals 49, and x equals easy. What about k? Loop-de-loop. You're gonna loop-de-loop all these. So what's this say when I loop-de-loop it? 2 to the third equals x, so x equals 8. That takes all of 5 seconds to do, if you know what you're doing. Now, don't be confused. This is just gonna have one little extra step in it. You're gonna loop-de-loop it like always. It's gonna say 4 to the second equals x plus 2. Right, folks? So 16 equals x plus 2, which means x equals 14. We always want to solve for x. Okay, what's m gonna look like when I loop-de-loop it? Ollie, what is m gonna look like when I loop-de-loop it? Say it again. Yep. Everybody in agreement with Ollie? So 9 equals 1 minus x. So if I subtract 1, and then multiply or divide by a negative, I got negative 8. Now n. I want you to look at n. You cannot loop-de-loop n right now. Why not? What's wrong with it? There's a number out in front. So what can we do to get rid of that number, Abby? You could, you absolutely could make this a squared. What might be easier though than doing that? That will work, you can do that, but it would be easier to do what? Just divide. We can divide both sides by 2. So we have the log base 4 of x plus 1 equals 2. If you make that a square, Abby, you're going to have a quadratic equation to solve, because it's going to be, 4 to the 4th equals x plus 1 squared, and then you'll introduce the possibility of extraneous roots. This way I think we're going to be good without that. So loop-de-loop it, what's it say? 4 to the second equals x plus 1. So what's x? 15. Last one before we go to the calculator. What do you think about L? Hey, wait a second. So you want to subtract the 6? Is that what you said? I like that idea. Subtract that 6 over to the other side. And then divide by -3. So the log base 6 of 4 plus x equals 2. And then Caroline, what's that say when I loop-de-loop it?
6 to the second equals 4 plus x.
Perfect. So 36 equals 4 plus x, and x equals 32. Everybody okay with that? Now, when I look at this next set of problems, they look an awful lot like the ones I looked at before. The difference is, this time, when I divide by 6, which will be my first step always, right? Always. I get 2 to the x plus 1 equals 3. What's different about this? There's no common base between 2 and 3. If this were a 4, or an 8, or a 16, everything would be perfect. Okay, so what am I going to do? You only have one choice, kids. What are you going to do? You're going to log both sides. You're exactly right, you're going to log both sides. So, when I take the logarithm of those sides, what's the beauty of that? What's the magic thing that happens now? E comes out here. So we have x plus 1 log 2 equals log 3. Now remember, you're solving for x. Ultimately, we want to say x equals. So what might we do? We have the options here. What are you comfortable doing? Dividing by the log of 2. So if you divided by the log of 2, you'd have x plus 1 equals log 3 over log 2. So log 3, close parentheses, divided by log 2, and then subtract 1. I got 0.585 basically. See the difference, kids, between the problems I can do without a calculator and the problems I need a calculator for? It's all about a common base. All right, B. We're going to do a couple more together, then you're going to come to the board. So there you go. Divide by 17. Always, whether you're using a calculator or not, you got to get rid of that number, that extra number. So, and we're not going to round that off. You're going to your calculator anyway, so just deal with it. ln both sides? Does it make sense to ln in this problem?
Yep.
Since there's an 8? So I'll ln both sides, and the beautiful, beautiful thing is, so all I have is x equals ln 93/17. 1.6994. Boy, that was easy. All right, let's try one more. We can make these look as big and scary as we want, but they're all the same, and they're really not hard. Sophia, step 1.
Sorry, I was just trying to figure out where
We're on problem C. I don't think I'm skipping one,
Divide
am
by
I?
50.
What do I do?
Divide by 50.
Yep, divide by 50. So negative 0.112x equals ln 4.
And then you divide.
And then we're just gonna divide. So we're gonna do ln 4 and figure out what that is. And then we'll take that number and divide it by negative 0.112. I got negative 12.378. If you're not getting my numbers, guys, you need to double check how you're typing it in.
Should we always round to the nearest thousand?
Whatever the directions say on the test or quiz, I don't think I put in directions in here, so, yeah, however the directions say. All right, everybody still on board? We've done a lot of problems today, got a few more to do. And then you're gonna come to the board. Okay, so let's look at number 3. This is another logarithmic equation. So we're switching gears. This is a logarithm equation now. So think about Mr. Miller loop-de-looing, but you can't loop-de-loo yet. What do we have to do first? Minus the 3.
And then divide by -2.
Everybody okay with that? Subtract 3. Now what? You still can't loop-de-loo.
Divide by -2.
Divide by negative 2. Now can I loop-de-loo? Yep. So 6 to the negative first equals x plus 2. What is 6 to the negative first without my calculator?
1 over 6.
1 over 6. So 1 over 6 equals x plus 2. So x equals 1 over 6 minus 2.
-11 over 6.
So you could say negative 11 over 6 or negative 1 and 5/6. I know some of you don't like dealing with the fractions. You just gotta grow up and do it. All right, let's see. How about E? E looks different. Can anybody tell me what's different with E and all of the other logarithm problems I've done today?
There's a log on the other side of it.
Exactly.
They just cancel it.
There's a logarithm on the other side. Now, when there's a logarithm on both sides, you cannot loop-de-loo. Okay? We loop-de-loo when we have one logarithm in the whole problem. Okay, that's when we loop-de-loo. If we have if we have logarithms on both sides, we need a different strategy. First thing we have to do is go back to what we talked about at the very beginning of the period. Does anybody remember what that was? When we had two logarithms and we put them together into one. How would these get put together into one? It would go together as a division. So it's going to be the log base 7 of 2x over 3. That one's not involved because he's on the other side of the equation. Okay, does everybody remember that from the beginning of the period? Now, common sense. If the the log of this equals the log of this, then what do you think about these two things? Don't they have to be the same? If the log of this hand equals the log of this hand, then they have to match. So we'll just drop the logs and say 2x over 3 equals 5. What do you mean? Huh? There's no name on it.
It's Maddie. She didn't feel like walking up here.
Maddie who?
Oreo.
Lazy bum. Alright, so 2x over 3 equals 5, so 2x equals 15, and x equals 15 halves. Now, I want you to notice something. When did I drop the logs? I absolutely dropped these out of the problem. I absolutely did. But I didn't do it at the beginning. Did you see that? You cannot drop the logs. Listen carefully, because you're going to get tempted. You cannot drop the logs until you have 1 log equals 1 log. So if you have 2, you have to put them together. Okay? All right, let's try one more of those. What about F? You got logs on both sides, so you know eventually you're going to drop them out, but not yet. What are we going to do first? We're going to multiply 4 and x. So this is going to be the log of 4x equal to the log of x minus 2. Now can I drop them?
Yes.
Yep. So 4x equals x minus 2. 3x equals negative 2, and x equals, oh no, we have an extraneous root. We haven't run into any of those yet. Take your calculator out and type in the log of negative 2/3. Just hit log negative 2/3. Error. This number right here cannot be negative. Okay, that number cannot be negative. Now, I need you to understand something because this can get a little tricky. If this had been x plus 4, and this had been x plus 2, it wasn't, but let's say it was, and I got negative 2/3, that would be okay. Because isn't negative 2/3 plus 4 a positive number? So it isn't the value of x that matters. It's the value of the whole thing you're logarithming. All right, let's get you up at the board. We have a lot of problems here to practice. Let's see. You can go by yourself or with a partner. And I may end up picking some of the ones I've already done because I didn't keep track of it. No, we're going to do our notes. Yeah, we're going to do problems.